Alrighty, hi everyone. So this is the bi-weekly contest 66. Let's see how it goes. And yeah, it's loading for a long period of time. Well, is my net slow? But so given two string arrays of word 1 and word 2, return the number of string that appears exactly once in each of these two arrays. Okay, exactly once. Cool. Return the number of strings or auto index to a, and let's make it as b over here. As that insert x integer answer equal to 0 for auto index to b. Over here it should be a if that appears exactly once in each of these two subarray. So what about the case when there is a repeating case, for example is and is? Tokens we do not count this string. Okay, cool. So we really have to just do it like this. Map of x plus plus map of string int temp of x plus plus for auto and x to m if map of x is equal to 1 and temp of x equal to 1 answer plus plus return answer. What is the compilation error over here? Map of string map of x dot first. Wait, what was the answer over there? So you're given zero index string street. Each character in the street is either H representing a house or dot representing an empty space. You can place the bucket on empty space to collect rainwater that falls from adjacent houses. Okay, the rainwater from a house at index I is collected if the bucket is placed at index I minus 1 or index I plus 1. A single bucket if placed adjacent to two houses can collect the rainwater from both the houses. Okay, return the minimum number of buckets needed for every house such that there is at least one bucket collecting rainwater from it, or minus one if it is impossible. So the answer will be minus one if there are two consecutive houses, right? Or there is no dot. Okay, so this is, thanks for letting us know this case. Okay, so for this house, for this dot, I'm having exactly two options, either to okay, makes sense. Cool. So for any given house, let's say I was having this condition, I know that this dot will be resulting in water being collected from these two houses, right? But what about that one house that is left? Okay, return the minimum number of buckets. So over here the minimum number of bucket is 2, over here the minimum number of bucket is 1, right? Basically I'm having this dot surrounded by these two houses, so I can collect it. Then I'm having H. So at max one dot can contain the can collect water from two houses, right? So is it a viable option to basically start from one house, right? Basically if a dot is surrounded by two houses, then put a bucket over there seems like a better option to me. For example, I can put a bucket over here, and then once the work is done, I can just skip it, right? Yeah, this seems slightly tougher problem for a B, so I think that, okay, this is a longer problem. We have to find the minimum number of buckets such that at least one bucket collects the rainwater and minus one. So the minus one case is pretty trivial, but we need to find a way to make sure that this house is being covered, right? Yeah. So how are we going to make sure that this house is actually being covered? So if two houses are consecutive, then answer will not be possible, or if there is no dot. Okay. I guess this is the only edge case over here, right? Other than this, there should not be any edge case. Okay. So the answer will be minus one if there is no dot at any edge, any pair of, like, there are no dots adjacent to this house. But what will be the minimum number of house, huh? Like I can put a bucket over here or I can put a bucket over here, right? How will I be able to find this answer? From both the house. So I should most likely just try to put a bucket in as many houses as possible which are not yet marked, right? And then I should most likely be taking the houses which are still left. Okay, let's do it. So first of all, let's find a case. Let's just print the case when how basically the answer will be minus one, right? So for integer I, integer n will be equal to s dot size. For integer I equal to 0, I less than n, I plus plus. If s of I is actually a dot, then I should be continuing it because this is not really interesting to me. Come on. Yep. Otherwise, what I should be doing is that I should most likely start from this house. If I plus 1 is less than n and s of I plus 1 is actually equal to a dot, then I should continue. Otherwise, I should repeat the same step for this. If I is greater than or equal to 0 and s of I minus 1 is actually equal to a dot, then also I should continue because then this dot can basically contain the water. Otherwise, I should be returning minus 1. So that's that. Now what I should be doing is that I know the gaps between two houses, right? Okay. Of boolean done, right? This means that the water from this house is already being collected somewhere, and the size of this should be an n. For integer I equal to 0, I less than n, I plus plus. If s of I is actually equal to a house now, then I should be continuing it, and I should most likely maintain this answer over here. This is maintaining the answer for one dot collecting water from two houses, right? So again, I should be doing this thing. I should be checking if there is even a single dot over here. If I plus 1 is less than n, right? Or if this is simply the last points, right? So if I is equal to 0 or I plus 1 or I is equal to n minus 1, then this is by default an extreme, right? I should be continuing over here, and then I do not even have to check this thing. Let's just ignore this thing over here, right? Otherwise, if there is even a single dot over here, I should be continuing it. Otherwise, what I should be doing is done of I plus 1 equal to 1, done of I minus 1 equal to 1, and answer plus plus. Now what I should be doing is I should check that which houses are left. So actually, let's mark this house as not something that I want to fill. I minus 1 or done of I minus 1 is equal to 0. Continue. Actually, we would have simplified this a lot, but I simply decided to roll with this thing, right? Answer plus equal, okay, if s of I is equal to dot is equal to h, answer plus equal to done of I. This is basically checking that if there is any house which is left, and once I'm done I should be returning the answer, right? Let's see how it goes. Not entirely sure if 2 1, okay, 2 1 minus 1 minus 1 0. Okay, let's submit. Huh, it actually got accepted. That's funny. I was thinking that there has to be some kind of edge case over here, but okay, seems like it's working fine. So minimum, there is a m into n grid where 0 comma 0 is the top left cell, okay, and this is the bottom right, m minus 1 n minus 1. You're given an integer array start position, okay, where this is the start position, start row and start column, and which indicates that initially a robot is at this, okay. You're also given an integer array home position where the home position is given to be this, indicating that home is at cell this. The robot needs to go home. It can move one cell in all four directions. It cannot move outside the boundary. Every move has some cost, okay. You're given 0 integer array row cost of length m and column cost of length n. If the robot moves up and down into a cell r, the move cost row cost r. Okay, so if it's moving up and down over here, the cost is this. If the robot is moving like this in this column, left to right in a cell whose column is C, column cost is C, okay. That is weird, but okay, let's see what's happening. For example, over here the row cost is 543, right? So it goes down to 2 comma 0, 2 comma 0, and since it was at goes down to 2 comma 0, this move costs row 2 of 3. So over here the cost to come from here is 3, right? Okay. Oh, I get it. Basically, if it is coming towards this row, right, this row from up, the cost over here is 3. But if it was coming from right to this particular cell, the cost was 8, right? Because the 0 is over here. Wait, why are there, okay, okay, 0 1 2 3 4, okay, okay, okay. Then it is going to 2 comma 1, the cost is 2. Then it's going to 2 comma 2. The cost to go to 2 comma 2 is what? 4. Wait, 6. Huh? 2 comma 1, 2 comma, okay, okay, 2 comma 3. Cool, cool, cool. So the cost over here is 18. Seems like a Dijkstra, but can we actually say that the optimal cost to reach over here is this thing only, huh? And the answer to that question is no, right? I mean, if I know the minimum cost to reach over here, then by default, the cost to reach over here will be some positive number, right? Is this thing right? Is this thing even right to say? Are the cost positive? Yep, the costs are indeed positive. So that's the brighter side that we are having. Okay. And if I'm changing the if I'm changing the j value, basically I would be doing I comma j. So if I'm changing the j value, I have to look over here. If I'm changing the I value, I have to look over here. Cool. A bit of this is making sense. And since, yep, I think that Dijkstra will work over here. By the way, what is the value of start position's length is, okay, okay, this thing makes sense. What is the value of, oh, m comma n is less than equal to 10 raised to power 5. So m into n can be around 10 raised to power 10. Cool. Now this seems to have become difficult. Okay. Can we say this thing that if I would have taken simply this thing over here, like I would have gone like this, is there any way that I would have come over here, then went over here, then came down? Is this even an optimal approach? Because over here I will be taking a cost of 1. This value is same for both the case, but this value is different, right? Because if I come down over here, I have to take a cost of 2 and I have to reach cost of 3 as well. So can we actually say that it is always going bottom or top down left? And since we have to take the minimum cost, I think that going down is the best option for me when the cost over here is the least, right? For example, over here, the cost to go down is least when I am at, you can start from 1 comma 0, it goes down to 2 comma 0, right? 2 comma 0. So the cost to reach the 2 comma 0 was 4. Okay. And then from 4, I'm basically taking a straight route over here. There is no point in taking a route which is going like this. Okay. So the cost over here would be 2 comma 6 comma 7. Okay, makes sense. But I have to go like this, right? I have to go like this, that's for sure. So the cost that I would be taking, like taking to move like this, would always have this value 267. And the cost to go like this, like I have to reach this column, right? Whether I come from here or come from here. Oh, wait a second, it's not that straightforward. Row cost of 2. I'm coming at this row, right? So I have to take this value 4. If I would have jumped from over here, the cost was 3. Nah, I'm just bullshitting at this point of time. Am I not? Cost over here would be 4. And then I'm taking these 3 values. Cool. 2 plus 6, 7, 7 plus 7, 14, 14 plus 4, 18. Okay. 0, 1, 2. Row cost R. If I'm up and down, I have to take the row cost of R. This is 0, this is 1, this is 2, right? So row cost of 2 is 3. And if I would have taken like any case, I would have gone like this, right? Still I would have to take this value. Wait, so do we just, is there only one unique answer? I mean, whichever path I'm taking, if it's optimal, that is, I am not going up because that I have proved is not optimal. If I'm simply going down and left, is the cost always same? That's the question, right? I think that cost will always be same, whether I go like this, whether I go like this. Because if I'm going like this, I still have to take this 2 comma 6 comma 7. And when I jump like this, I have to take this value row of 2. Oh, I get it. So I have to calculate the suffix, like whichever value. Okay, I understand what I have to do. Yep. So this is the home position, right? So integer x initial will be equal to home position 0. Integer x final will be equal to home position. Nope, 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 nope. Start position 0, home position 1, 0. We can actually break this problem in two parts. One is to calculate the answer for x and other is to calculate the answer for y. Okay, so let's just break this question in two parts. This function will be giving me the answer for both the parts, right? First of all, I will be having the cost, the vector of cost which I want to calculate. So which direction. So this will be vector of int of cost. Then I know the initial position, that is A. I know the final position, that is B. Now I can have two cases, right? One will be when A is less than B. Okay. For integer I equal to 0. Cool. So if A is less than B, what I have to do is I have to start from, let's just name it as start and final only. it's a bit easier to code, because this thing is not given that what will be the position, like is there any relative positioning between home and start position. I have to work on two values. Okay, so for integer I equal to s plus 1, I is less than equal to final I plus plus, what I have to do is integer answer will be equal to 0. Actually, I can find this answer in one loop only. Just change the increment value. If start is less than f, increment equal to 1. If start is greater than f, increment equal to minus 1. Right? And if start was equal to f, I should most likely be returning 0 over here. This is the best option for me. Now for integer I equal to s plus increment, I... oh shit, I have to work into codes. Cool. If start is I is not equal to final position, for integer I equal to s, I is not equal to... what exactly am I doing over here? I'm simply trying to save my time in coding up two for loops, but now I think that I should have coded it. But let's roll with this thing only. So I'm having an answer plus equal to start, and if start is actually equal to final, then I should be breaking it, right? Once I am done with this, I should be returning my answer. I have checked this thing. This value is checked. If start is less than final, I should be incrementing. Otherwise, I should be decrementing. Then I should not be taking the value which is over here. S plus equal to increment. And once I am done, I should be returning it. Yep. Now what I have to do is calculate the answer for both the case separately and print it. So return func of, first of all, start position, final position, right? This is for x and this is for y. Now s of 0, final of 0, x plus func s of 1, final of 1, and y. Y is my brother playing a goddamn EDM in which I want to dance. Man, he's really creating a vibe in which I want to dance instead of giving this contest. Will I be getting... ah, crap. I'm an idiot. It's plus equal to increment. 18! Yay! Use example test case. 18 and 0. Yep. That is the case. Now let's see. Ha! Got accepted. Nice. What's the standing? How many people have solved this question? Guess there has to be good amount of people who have solved this because it's not that difficult. Yeah, the number is okayish. Okay, this was an easier problem and I was thinking this was tougher than that. Oh, this seems like a fun and tough problem. So a farmer has a rectangular grid of land with m rows and n columns that can be divided into unit cells. Okay, each cell is either fertile, represented by 1, or barren, represented by 0. All cells outside the grids are considered barren. Amazing. A pyramidal plot of land can be defined as a set of cells with the following criteria. The number of cells in the set has to be greater than 1, and all cell has to be fertile. The apex of pyramid is the topmost cell of the pyramid. The height of the pyramid is the number of rows it covers. Let R comma C be the apex of pyramid and its height be h. Then plot the comprises of cell I comma j where I is less than equal to R, less than equal to R plus h minus 1, and C is C minus I. एक मिनट क्या? Plot comprises of I comma j such that whatever the value of I is, it is from this to this, okay, and whatever the value of C is, its range is from C minus I minus j, okay, to C plus I minus R. C plus I minus R. Huh. Alrighty. An inverse pyramid of land can be defined as a set of cells with similar criteria. The number of cells, हाँ ठीक है, already makes sense. Some example of valid and invalid pyramidal and inverse pyramidal plots are shown. Given a zero index m into n binary group representing the farmland, return the total number of pyramidal and inverse pyramidal plot that can be found in grid. Huh. Alrighty. I hate this problem already. Okay. So clearly for each cell, I just need to find the number of consecutive ones, right? And then I have to make one particular cell as center and check if there are, like, what's the height right above this cell and what is the situation beneath this cell. Yeah, that can be one of the way of solving it. And then what I can do is that I can actually rotate this whole grid by some angle and then again calculate the answer. But this will result in some repetition of cases when there is only one grid, right? So in that, oh, no, this is invalid. Wait, what? Okay, the height has to be greater than 1. Okay, cool, makes sense. So I have to subtract the dp of 2, right? Yep, I have to subtract that value, dp of 2. Cool, makes sense. Seems like an interesting problem. Isn't there any inverse? Okay, there is no inverse pyramid over here. Okay. Seems like a DP problem. Let's see how many people have solved it. Yep, 24 people have solved it because it is a DP problem. Only thing that you need to keep track of is this DP of 1. Okay, cool. Makes sense. So for each cell, I just need to keep track of what is the maximum height over here, right? Because once you have kept track of that, you are pretty much good to go. Okay, let's see how it goes. For example, answer over here is 0. And then there are some cases. Cool. 2, 3, 1, 2. So the height has to, the number of values has to be odd, right? Like whatever height is over here. For example, over here, the height was 1, 2, 3. Then there has to be 2 cells over here. There has to be 2 cells over here. I guess we can find it. M into n is less than equal to 10 raised to power 5. Yep, we can do it. The only thing that would be funny is that how are we going to rotate this matrix, right? Because we have to find a way of basically rotating it. So for rotation, what I can do is that I have to take this column, reverse it, and put it at the back. So basically swap this thing, then swap these two things. Yeah, it's possible. We can even rotate this thing with no issue whatsoever. Because this is same as calculating the answer for reverse case, right? So yeah, let's start. Enough of time wasted. Let's try to finish this contest relatively quickly. So I'm having a function again, integer func, which will be integer, let's call this calculate, which will be taking a grid like this, and what it will be giving me is the answer for this case, right? Basically finding the answer for basically finding the answer for non-inverse matrix. It will be giving me the answer for this non-inverse matrix, right? Normal matrix, normal pyramid. So what I can do is that I can then calculate the answer for inverse by rotating this whole matrix by 180 degree. Yeah, okay, that's that. Let's start with the code then. So first of all, I'm going to take its size, integer n, and integer m will be equal to g of 0 dot size, right? M and n are greater than or equal to 1, so that's good. Now what I have to do is maintain this dp thing, right? So vector of int dp. What about the case of when I know that this height, for example, over here there is this case na jab, wait, what? Okay, they have not given us all the cases. That's good. Cool. Let's start. dp of n comma vector int m for integer I equal to 0, I less than n, I plus plus, for integer j equal to 0, j less than m, j plus plus. First of all, I will be doing the prefixed sum over here because I need to find the number of consecutive ones over here, right? So for this, I will be doing prefix sum. Actually, do I even need prefix sum? I can simply calculate the number of consecutive one over here, right? In the left direction and the right direction. So m and m. And if j is actually equal to 0, let's just maintain a count over here also because I'm just lazy. That's why. If j is equal to 0, count is equal to 0, else count is equal to count plus plus. Left of m will be equal to 1, right of left of m will be equal to count. Copying this thing over here, right of m will be equal to count, j equal to m minus 1, j is greater than or equal to 0, j minus minus, and I should be doing g of ij over here, right, instead of just j. Everything seems fine. Counter plus plus, count equal to 0. Yep, so this thing seems fine, right? Now what I should be doing is that I should try to find the answer for each case. So for integer j equal to 0, j less than n, j, actually I can calculate the answer over here only, right? G of ij equal to 0, right of m will be equal to count, right? dp of ij will be equal to, so integer mini will be equal to dp of I minus 1 j, right? Initially the mini's value will be 0, and if I know that there is a row right above this, if mini is greater than 0, then mini will be equal to dp of I minus 1 j. J equal to 0, I should be continuing it. Yep, that makes sense. Right of m will be equal to count. Integer mini is equal to 0. If I am having a row right above this, mini will be equal to min of comma dp of I, right? Otherwise the value of mini will be equal to min of, I have to take three values. First is this mini, the second one will be this dp of I minus 1, not dp of I minus 1. How many consecutive ones are there towards its left, how many consecutive ones are there towards its right, right? And yeah, this is the whole case. For example, over here the number of ones are 1, over here the number of ones are 2. Cool, makes sense. And simply make this dp of ij as equal to mini, or mini plus 1. It will be equal to mini plus 1. And since the value of gij is actually 0, I'm continuing from here. The minimum value of dp of ij will always be equal to 1. So that's that. And once you are done, I guess we can move on, right? So we have calculated the answer. Now only thing left is returning it, right? So for integer I equal to 0, for integer I equal to 0, I less than n, I plus plus. We should calculate it right over there only. I'm an idiot. Integer answer equal to 0, right? So answer plus equal to dp of ij minus 1. This is what? This is simply keeping track of what is the answer for all the grades minus that one case of having this one cell as the answer, right? And once you are done, I can return the answer. So first of all, let's calculate this for this grid, calculate of grid. Then what I have to do is for integer I equal to 0, I less than n, I plus plus, reverse what? Reverse this grid of I dot begin, grid of I dot end, right? For integer I less than n by 2, then reverse grid of n minus I dot begin, grid of n minus I dot end, minus I minus 1, minus I minus 1, and then swap these two values, right? So grid of I, grid of j, oh, not swap, grid of I, comma, grid of n minus I minus 1. Yep, this makes sense. 0, 1, 2, 2, 3. So for this case, I guess I should be able to get the answer right now only. 2 into I is less than n, right? For example, over here 0, 1, 2, 3. So 2 into 2 was 4, which is clearly greater than 4, so I would not even be going over there. Yep, makes sense. And if n is odd, then I should just be reversing this value, right? Reverse grid of n by 2 plus 1 dot begin, comma, grid of n by 2 plus 1 dot end, and then again calculate the answer for this grid. Let's maintain the answer over here. Answer plus equal to calculate, answer plus equal to calculate, and let's return this answer. Yay! What the fuck was that? Ah, crap. Where the fuck is the mistake over here? For integer j equal to m minus 1, j greater than or equal to 0, j minus minus. Yeah. There can be bunch of issues over here. For example, this over here, right over here, grid dot size. Now what? Reverse n. You have got to be kidding with me. Now are you happy? Oh, runtime error. That sucks. Let's see if I simply remove this thing. Like, let's just remove this thing. Okay. Let's keep this thing over here alive. Now let's see what happens. Oh, I should be returning the answer over here as well. Oh, still runtime. Wow. Why exactly am I getting runtime over here? If I is there. Okay. So let's see when I will be getting runtime. 2 comma 4. Okay, this seems to be working fine. For integer I equal to 0, I less than n, I plus plus. For integer j equal to 0, j less than m, j plus plus. For integer j equal to m minus 1, j greater than or equal to 0, j minus minus. Okay. C out for auto and x to L, C out x, and then C out E and L. Hey, this is exactly where I'm getting runtime error. Wow. What's the issue over here, huh? Oh, left of I is equal to 0, right of I is equal to 0. God damn it. Am I an idiot or what? And now it's working fine. See? Tada! 0, 0, 0, 0, 4. Wait, what? Else count plus plus. Left of I will be equal to count. God damn it. 4. From where exactly are you getting this 4? If g of ij is equal to 0, where exactly is this value getting 4 over here, huh? 4 auto. C out g of I j. Let's print it. 0, 1, 0, 0, right? Okay, so this makes sense to some extent. But when I'm incrementing this value, why is this not making sense? Oh, because this has to be left of j. This has to be right of j. Man, there are some bugs in this code. Yep, 0, 1, 2 and 1, 2, 3, 4. Okay, this makes sense. Now, where exactly am I making a mistake over here? Count equal to 0 if right of j will be equal to count. Okay, and then simply making track of mini over here, right? If I is there, then mini will be equal to min of dp of I minus 1j comma mini. I have to print the value of mini. That means for auto and x to dp, for auto and y to dp, x, c out y, and then c out e and l. Man, I made some insane bugs over here. 0, 0, 0. Okay. Why is the value 0 over here? dp of ij is actually equal to mini plus 1. Oh, I got you. What has happened now? I understand. Left of j minus 1, not I, you dumb idiot. Left of j minus 1, right of j minus 1. Now it makes sense. God damn idiot. Let's take a break. Yep. So what was the answer for this case again? It was only 2, okay? Now, have I done the reversal part right? That's the question. Huh? What? But why? Reverse this value for auto and x to grid, for auto and y to grid, x, c out y, c out e and l. Have I not done the reversal well enough? Oh, okay. What was the answer for this case again? It was 2, right? Yeah, why is this throwing the answer 1 over here? Oh, I got you. I got you. Else mini will be equal to 0. Yep, now it makes sense. So let's just comment this thing out. Let's comment this thing out and let's run this on the example test cases. 22013, 220 and 13. Okay. And am I printing anything? I am not printing anything. Now hopefully the TLE. Ah, crap. 000. For this case, I'm having. Okay, that's weird. 1, 2, 3. For this, the median, the mid value. Wait a second. 0, 1, 2. I'm an idiot. I have to be the biggest idiot. 0, 1, 2, 3, 4. Just the case over here. Okay. 0, 0, 0. 0, comma 0, comma 0. Let's run it. Give me daddy C. Finally. What an absolute idiot. I have to be the world's biggest idiot because I simply made that idiotic runtime error. I should have had checked at least one case when there was odd value, but okay. Let's see what is my ranking in this contest. What's my ranking? God damn, it's 290. Not good. Wait, is this my real rank or what? 23 minutes, right? Okay, okay. I have taken quite a bit of time. 40 minutes, 46, 38 minutes. The people over here have taken 38 minutes. 43 minute. Okay, it should get updated to something under 200. Let's see when it gets updated. So when will it get updated? 1 2 3 4. How much time I have taken? 46, right? Like it would be somewhere over here. Not the best ranking. What's my overall time? 51 minutes. Man, it would have went so much well. Yep, here I am looking at the failure of this one bug. God damn it. But yeah, this was the screencast. Hopefully, you guys understood how to do good if you are panicking like crazy. So, yeah, do check this out if you enjoyed.